All right, well, welcome everyone to the National Association of State Energy Officials virtual roundtable on electric grid sensor technologies for resilience and affordability. My name is Kelsey Jones, and I am a program director with the electricity team here at NASEO, and will be working with my colleague Kirsten Verklas to moderate and facilitate the discussion today. So just for some brief background, state energy offices are looking for opportunities to advance resilience, reduce emissions, and prioritize affordability of the electric grid. We've really found that sensor technologies are a strong potential path forward to support these and other state policy objectives. Grid sensors can collect data, help with increasing power flow, and ensure reliability during man-made and natural hazards. And so over the course of this 2-hour virtual roundtable, we have a series of expert speakers from the federal government, state government, and private sector who will share remarks on different use cases for grid sensors, what potential funding and financing mechanisms are available, and how states can best coordinate with utilities on deploying sensors. And just for everyone's awareness, this is a Zoom meeting, so everyone is able to unmute, turn their cameras on and off as they wish. We just ask that you please hold off on sharing any comments or asking any questions until after the 4 presenters are finished with their remarks. But please feel free to add any questions to the chat as they come to you, or just hold them into the Q&A portion. And at that time, you'll be able to raise your hand, unmute, or add additional insights into the chat function. Before I turn things over to my colleague Kirsten Verklas, I just wanted to thank the U.S. Department of Energy's Office of Electricity for their support of this virtual event. Kirsten, over to you for a brief introduction and background on grid sensors.
Great. Thank you so much, Kelsey. And hi, everybody. My name is Kirsten Verklas. I'm Senior Managing Director for Electricity and Energy Security at NASEO. And I'm really excited about today's virtual roundtable. This was an idea that was sparked by Pat Hoffman, in fact, and David Terry while she was still at the Office of Electricity. She's now at the Grid Deployment Office. But it came out of the realization that grid sensors are something that, as Kelsey said, can really help bring the electric grid into the 21st century, but it is something that I think a lot of state energy offices, and myself included, are not as familiar with as maybe we should be. And so I wanted to just kind of set the scene. I know our presenters will delve into a few of these items, but I wanted to set the scene of kind of what are grid sensors, how we're thinking about that, what kind of challenges could they maybe apply to, and really also hone in on the fact that there are different sensors when we're thinking about the electric grid. Some on the transmission side, some of the distribution side. You hear some of the technologies thrown around today. I think today we're probably going to focus more on the transmission side, but if there are any questions on the distribution side, please also feel free to raise them as we're going into the kind of interactive portion of today. But as Kelsey mentioned, there's a lot of challenges that we as a nation and the electric grid is kind of confronted with. A lot of the infrastructure of the electricity grid in the US is aging. This is compounded by the fact that we have an increase of severe hazards, which are causing droughts, wildfires, hurricanes. Climate change is exacerbating some of these issues, coupled with the fact that there's a rise of distributed energy resources. So the electric grid doesn't look like, 20, 30 years ago, where it was sort of one directional. It's now bi-directional. People are generating their own electricity. There's an increased demand. I think that's sort of maybe the new wrinkle that is being thrown at us. I think electricity demand in the past has been sort of flat and steady. But with the rise of data centers and the rise of electrification of buildings and electric vehicles, we're really seeing an increased demand of electricity, and I think it's just going to continue. And then there's changing consumer preferences with sort of the DER proliferation. People are also thinking about how they're consuming energy and what are sort of their preferences are, and they're starting to rethink maybe what the grid looks like to them and how they want to use the grid. So sensors really can, address a lot of these challenges. They can provide greater visibility into the electricity grid, and this is not just for resilience and reliability purposes, but also potentially for providing data and economic benefits when you're thinking about DERs. They can also, look at and provide different customer service and lower response time in case of outages. And they can also really provide an increased longevity of assets. As I mentioned, the aging infrastructure is a challenge, and so sensors really can potentially help us prolong some of this infrastructure's lifespan. Now, some might kind of wonder, well, this is really a utility-focused issue. What is the role of the state energy offices? And I just wanted to highlight a few items. One is that I think the role of the state energy offices is really changing in the sense that through the IIJA, they've been tasked with implementing a lot of the grid resilience grants, the state and tribal grid resilience grants under 4101D. They've been asked to join in some of the proposals under the GRIP awards through GDO, and they're really thinking about some of the risks and risk mitigation strategies that are apropos or applicable to the electricity grid when they're thinking about state energy security plans, which a lot of the state energy offices are in the process of writing and updating. So that's why we thought today would be a really good workshop to kind of provide you with that information and help the state energy offices tackle some of these issues. Before I turn it back over to Kelsey, I also wanted to highlight a few things that I will put in the chat. One is that NASEO is kicking off a few additional working groups to kind of help the state energy offices think about some of these issues. We will have a transmission working group and a distribution working group as part of our electricity committee. And I fully think that the sensors and some of the technologies we're talking about today will resurface in those working groups. And we're also launching a data working group, which will look at how can some of this data that we're collecting from the electricity grid, from the building sector, from the transportation sectors be harnessed and supported in understanding how we're reducing greenhouse gas emissions and how we can track that. So I will put in the chat the NASEO website where you can sign up for that, and you'll see if as a NASEO affiliate or state member, you will see a data push and an email come out later this week or early next week. And then I will also put in the chat a new effort that the Lawrence National Berkeley Lab, together with DOE, has started, which is a really concerted effort to provide technical assistance to state entities, specifically state energy offices and public utility commissions. And they're working with NASEO and NARUC and supporting our members to take advantage of that. And I think that is a really critical and key approach to provide you all with technical assistance that is geared towards just answering very basic questions to full on lab supported technical assistance that takes a few hours to complete and has all that analysis tools that you need. So I will put a link to that in the chat as well for your information, and then hopefully you'll be able to take advantage of that. But with that, I will turn it over to Kelsey to walk through the logistics for today.
Thanks, Kirsten, for that background, and you can move to the next slide. So this slide just provides a high-level overview of the agenda for the virtual meeting today. As you can see, first up, we have Patricia Hoffman, Principal Deputy Director with the Grid Deployment Office at the U.S. Department of Energy. She will share an overview of sensors, machine learning, and IT infrastructure from the federal perspective. Following Pat will be John Parks, Electricity Markets and Transmission Policy Analyst with the Colorado Energy Office, providing an overview of the state's Advanced Grid Monitoring Grant Program. And these presentations will be followed by two speakers from the private sector, Giri Iyer, Vice President of Business Development with Sentient Energy, and Kartik Rao, Vice President of Client Success with Line Vision. And so after these expert presentations, as I mentioned earlier, there will be time for Q&A and open discussion, followed by facilitated breakout conversations among attendees, really to do a deeper dive into state activities to accelerate deployment of sensors, advance utility coordination, address different challenges, and other considerations. So with that, I will turn things over to Patricia Hoffman to kick things off with some slides.
So great. Thank you, Kelston. Thank you, Kirsten, for having me here today, but also thank you for hosting this seminar today. I think it's a very important topic as we want to move forward and take advantage of everything that we have to offer with the investment of sensors and then allowing for the data analytics, the machine learning, and all the infrastructure that's really important to accelerate this opportunity. So next slide, please. So the Grid Deployment Office is currently investing $26 billion in capital, looking at investments across the electric grid. Primarily, our approach is really concentrating on two things. It's really transmission capacity, for the sake of this seminar, transmission capacity, and really looking at investments in our transmission system and looking at capacity that will help both with resilience, but the integration of clean energy, and then improving resilience. In transmission, we have several financing tools that are available, and we're supporting numerous projects in the transmission space. But in the grid resilience strategy space, we really want to provide additional tools that help with assessing the best solution, some of the technical assistance that was mentioned earlier, and then thinking about how to prioritize our investments as we move forward. We recognize this is going to be investments over time and investments that we know must maintain pace with as we see extreme weather change, as we see challenges to our electric grid continue to evolve. The last part of our resilience strategy is really thinking about how do we prevent, how do we do that mitigation, response, recovery, and restoration process as efficiently and effectively as possible. As we look at our investments and the topics of this seminar today focused around sensors, there is a huge opportunity really to think about what sensors can do and provide with the associated data analytics and machine learning, and really be able to capitalize on sensors as we move forward. So some of the opportunities as I look at it, we have the traditional opportunity that I think is well defined out there with respect to asset health and predictive maintenance. We look at predictive failure of transformers and other grid components. Sensors looking at the health of our assets has been a strong foundational activity and growth in the utility infrastructure to really capitalize on operations, lower costs, and improve system performance, and also prevent some of the outages and some of the events that occur in the system. Some really newer areas that we look at with the opportunity of integrating sensors really continues to grow from the planning and modeling perspective of the electric grid, and the investments of how to improve what I would say the operations of the electric grid writ large. So one type of game-changing activities that you may have heard about is grid-enhancing technologies. Grid-enhancing technologies are technologies that help the grid operators increase the electricity current carrying capacity and performance of existing assets. This includes sensors such as dynamic line ratings that really assess the grid conditions and really help dynamically optimize the utilization of the transmission system based on condition-based monitoring of transmission lines. So this really can help us look at overhead lines, operate closer to capacity limits, but utilize our infrastructure more effectively as we are enabled with real-time sensor data. So that's one of the things that I wanted to highlight as a potential opportunity moving forward. I was also asked is, where is the state of the art with respect to sensors and research and development from our perspective? And from this, I'm going to pull from my sister organization, the Office of Electricity, and highlight some of the work that they're doing. In the past fall, OE showcased in this space a whole set of workshops that really looked at transmission and distribution data and information. It looked at the state of the research with respect to transmission investments, but information sharing, sensors and systems and platforms, sensor data, and device research. It was a great series of workshops. I'll put the link in the chat so that people, when you have time, can go look at some of the results of the workshop. But really it focused on sensors, data analytics, and how utilization can really advance grid operations and controls. So some of the things that they focused on was data at the distribution system as well as the customer edge. How can sensors and getting that historical performance really help us fine-tune forecasting and operational analysis? How can data help control an operation help control and operations of the electric grid. Think of relays and looking at the utilization and support of that for that, as well as coordination from the T&D perspective. So research going into specifics can look at oscillations on the system. How can sensors help us define where oscillations are occurring and where the origination of oscillations are, as well as load profiles. I believe Kirsten brought up already the growth of data centers and really demand growth. So how do we continue to look at that from, say, a meter perspective and looking at where do we need additional capacity on the transmission system, but as well as the distribution system. One project through the Grid Modernization Lab Consortium that I wanted to highlight is at NREL. They're really pushing the envelope with the utilization of sensors to create a microgrid digital twin. And they did it in the city of Cordova, Alaska. And so where Alaska is looking at a microgrid, they're looking at lab to do microgrid controllers, but integrate that with smart meters and create a real-time digital simulation of the system. And so that's really a forward-leaning opportunity as they really try to emulate what's happening on the distribution system from a microgrid perspective. Now, I was asked really also to think about how can the states best support sensor deployment and through your plans and programs. And really, as I think about what NASEO can do and what the states can do, is really think holistically from a sensor perspective of the deployment of sensors at scale, so you have enough critical mass with respect to data, but then also the data analytics, the investment in the infrastructure that will allow for machine learning and advancements in understanding performance. So other things that the states can do is help set the policy looking at standardization of data, a common information model. So data can be aggregated at a larger scale and be able to be utilized for maximum potential regionally from a grid perspective. Other things that the states can do in helping support sensor deployment is really think about some of the privacy policies and procedures for data sharing so that we can encourage, but also enable capitalization and utilization of sensor-based data for tools and enabling services to consumers. So on the next slide, please. I wanted to wrap up and just talk about how GDO is engaging in these efforts. Of course, through the bipartisan infrastructure law under the GRIP program in 2021, we invested and announced 10.5 billion in a competitive grant program to really look at that flexibility. The first round of GRIP funding was 3.5 billion, and it supported 58 projects in 44 states looking at grid resilience through the Innovative Partnership Program. Likewise, this is catalyzing more than $8 billion of public and private investments. So a great partnership program looking at the advancements. One project that I wanted to highlight as part of this, it really takes another dimension from a resilience perspective for utilization of sensors, which goes back to a point that I want to make that goes, it is more than just utility sensors. When we think about resilience, we really want to think about capitalization of all kinds of data that can be compounded for the benefit of industry and the consumers. So one example that I wanted to highlight really is digital twins, sensors really being able to help with wildfire mitigation. When you think of lidar data, you think of weather data, you think of drought conditions, you think about vegetation, fuel loading, and location of transmission assets. You can bring a lot of sensor data, but also other data into collection and really think about the opportunity to really detect the thermal overload, but also look at risk from a wildfire perspective. So the sensors on the transmission system really can be monitoring the current and thermal load of the surge arrestor. And what that would do is help detect any sort of thermal overload. One of the projects under the GRIP program, Holy Cross Energy, is launching a wildfire mitigation project in coordination with NRECA. And it's really a combination of 38 co-op utility partners that are going to look at sensors as well as data and modeling technologies to analyze, prepare for, and mitigate potential impacts of utility-ignited wildfires. So what's next? We're continuing to roll out additional funding through the GRIP program. We had the second round announcement up to $3.9 billion that was announced in November 2023. We're right now in the process of reviewing the applications that will come in that are due April 17th. My apologies. We reviewed the concept paper. And so we're well into the next stage of that solicitation. As well, you guys are very much familiar with the formula grants. On January 18th, we opened the next round of allocation requests for the formula grants for fiscal year 24. So there is additional funding for the states, territories, and tribes to invest in formula grants. And then on the R&D side, OE has a sensor solicitation out. If folks aren't aware of it, the applications are due April 4th, but it's a great opportunity for partnerships. And then to close out, I wanted to touch back on one thing which was brought up earlier, is technical assistance. We have a huge opportunity to really leverage the modeling capabilities of the national labs, the analytical capabilities of what the department and the national labs have to really help states look at the risks from a resilience perspective of extreme weather and other conditions to their system, in addition to, say, heat and demand profiles and demand changes, to think about how do we prioritize investments? How do we really efficiently and effectively use those investments from a cost effectiveness perspective as we continue to invest in our electric system? So with that, I would like to thank you for your time today and turn it back over to Kelsey.
Thanks so much, Pat, for that overview, and we'll be sure to add a link to the Grid Deployment Office's webpage into the chat. But for now, I'll turn things over to John Parks with the Colorado Energy Office.
Great. Thank you so much, Kelsey. And thank you, Patricia, for that great overview of all the great work that's happening at DOE right now. In terms of grid resiliency and all the grant programs that are happening, it's definitely go time right now. And so, you know, I'm from as Kelsey mentioned, the Colorado Energy Office, just here to share a little bit about our approach in the great state of Colorado to grid resiliency. And it was nice to hear a couple of different Colorado-based organizations that Patricia called out, like NREL Laboratory and Golden and Holy Cross Energy up in the mountains. Next slide, please. So, you know, as Colorado is becoming hotter and drier due to the impacts of climate change, our utilities are and their customers are more and more vulnerable to the risks of larger, more intense wildfires that threaten more communities, worsen the air quality, and increase the frequency of electrical outages across the state. I think that 2020 was definitely a wake-up year for us in Colorado, as well as across much of the West. We had our worst fire season in history, and we had kind of, if you'll pardon the pun, lit a fire under the butts of the utilities to make sure that they, you know, didn't fall into the same category as some other utilities in other states, such as California and more recently in Texas, that may have been responsible for some widespread and catastrophic wildfires. So, you know, looking at the different investments that can be put into hardening our grid from wildfires, I think that you know, probably, you know, the most effective way is some of the traditional grid hardening approaches. You know, undergrounding resources. You know, the vegetation management, moving those trees away from the lines, replacing the old conductors. But those are also the most costly. And, you know, despite the fact that we have this once in a generation funding opportunity from the bipartisan infrastructure bill and the IRA, it's still not quite enough if we were just to take that traditional grid hardening approach. And because the grid monitoring provides a higher tech, much more effective and efficient way to really address a lot of these concerns that are being raised, and really kind of strategically pinpoint the approaches and what to do. So, we are kind of taking a three-tiered approach to addressing wildfire risk in our state. The first is integrating smart grid functions to prevent wildfires. And so that's increasing the SCADA systems that connect the grid operators to their resources in the fields. And also advanced grid modeling automation. So opportunities for utilities to really create a full model of their grid and all the assets on there to really pinpoint, well, where are the pinch points? Where are the areas that need most attention on a more frequent basis, so that they're better able to deploy those resources when and where needed. Also looking at anticipating and mitigating the impacts of wildfire on the grid. So we know that there is going to be wildfire. Wildfires are part of our ecosystem here in the West. It's necessary for our forests to regenerate, and it's so dry that when the trees fall, they don't decompose. And so if we were to have a situation where there was no wildfires, we would have forests just stacked up high with deadfall. So we know they're going to happen, but it's a matter of identifying them and responding to them. So remote HD cameras, these are these AI controlled cameras like Pano produces, put up on a mountaintop or on a communications tower, and they can spot those smoke or wildfire as they initiate, and it cuts response times dramatically. It also increases the opportunity for more integration and sharing of information between both the utility, who may or may not own the asset, but also local emergency managers and communities. Also looking at advanced grid monitoring, which our colleagues Giri and Karthik will be talking about more in the next section here. Looking at automation software as well. And then we're also looking at ways to increase the ability to redirect or shut off the power, so to minimize blackouts. We all know that outages are not what we want to have, and they're to be avoided, but sometimes in these situations that they are necessary. So there's the automatic reclosers that disconnect the line if there is a short in the system. And then one of the things I found really interesting is non-expulsion fuses. I believe that most people on this call are working at energy offices like myself. But we all, the distribution lines have fuses, just like the fuse box in your house. But instead of being a switch that you gets tripped and then you just have to flip it back, most of the traditional fuses in distribution lines actually explode when they are overburdened, and they have some oil in them as well to help that process. But unfortunately, that doesn't work with the dry climate here in the West, and it can cause wildfires. So there's a big conversion process happening from these expulsion to the non-expulsion fuses. Next slide, please. Patricia mentioned there's the GRIP program, and we did apply last year for a GRIP application. This was a state-led topic 2 application. We had 16 different utilities that covered 65% of the state with their service territory and 77% of the Colorado residents. It's a pretty neat partnership, getting all these different folks together, both from co-ops and investor-owned utilities and munis, and getting them talking about, well, what are the solutions that we're looking at? How can we work together? And then also getting them to move out of their silo and work with the local communities. I think we had 30 different letters of support from local communities, as well as the governor. Next slide. Unfortunately, it was not awarded. But these are competitive grants, and so this was a risk that we knew going into it. I think as Patricia can well attest to, the GRIP in the round one was more competitive than anticipated, and I'm sure this next round will be even more competitive. But it did initiate a great dialogue, both internally at the utilities, thinking about what are some of these high-tech solutions that they can employ to reduce wildfire risk, as well as engaging them with each other and their local communities. Next slide, please. So we do have the formula funding, and so this is that $14 billion nationwide that is allocated to all the states, tribes, and territories. It's a five years of funding. Here in Colorado, we have received about $8 to $8.5 million per year for the first 3 million years. If we anticipate that over the full 5 years, there'll be about a $40 million investment. So if you look here in the middle, well, there's actually 3 programs and 1 study and admin area that we've allocated this funding to. We have kind of a unique approach. I understand from my federal program officer at DOE and NEDL that most states are kind of focusing into just 1 program. But with the grid hardening, that's something that we anticipated. Okay, there's going to be interest in this, and it's probably going to be that interest is going to far exceed what we can actually provide. And so we put some funding into that, about $4 million, and that was a bit oversubscribed, which we anticipated. But it's meeting some of the needs of the small and rural communities. We also put we have a policy to kind of support microgrids as a resiliency approach. And so we actually put a little bit more funding into that. But we also set aside $2 million in the first round and $2 million in this next round, with the applications due in a few weeks, towards the grid monitoring. So I'm going to talk about that for a moment. And also in terms of the microgrids, we're also this funding is supporting a microgrid roadmap that is looking into ways to the benefits of microgrids and ways to better deploy those. Next slide. So yeah, there's that advanced grid monitoring program I was just talking about. So the advanced grid monitoring grants, we are capping it at $500,000 per grant. And so if utilities were to go for the full amount, there would be 4 available at this level. In the first round, we had about the same amount available, and the utilities asked for what they needed. They didn't go all the way up to that $500,000 mark, and there's actually 6 different projects that we have recommended to DOE that they be funded, and they're currently going through the review process there. And and as anybody who's working with this funding knows, the smaller utilities have a local match of 1/3, right? And that's if they produce less than 4 million megawatt hours, or sold less than 4 million megawatt hours in each of the recent years. Whereas the bigger utilities have a 100% cost match. And just as a quick aside, if we think about a $400,000 project, there's 300,000 that are put in by the federal government, and 100,000 from the local entity. So that's a 3-to-1 cost match. But if you think of a cost share, it's actually 25%, because that's 100,000 over 400,000. Whereas the larger utilities, for the same project, they would have to put in 200,000 for the Fed's 200,000. So it's a 1-to-1, but then it would be a 50% cost match. So interesting how that works. 1/3 to 100% cost match actually goes from it actually doubles the amount that the utility puts in, not triples it. So next slide, please. So this grant is for all different types of technologies. We've got fire monitoring, prevention technologies, some of the advanced vegetation and fuel load management that uses LiDAR, AI, or other information technologies. There's distribution pole sensors that collect all kinds of data and share it with the grid operators, smart meters, grid modeling, and any studies that are needed to identify where best to locate these devices. That is what we're doing here in Colorado. And thanks again for having me. And I'll pass it back to Kelsey.
Thank you, John. Always great to hear the exciting work underway in Colorado. I'll turn it over to Gary now with Sentient Energy.
Yep. Good afternoon, everybody. Thanks for the time here this afternoon, to the speaker, to the organizers here. Next page, please. So today I wanted to speak to you on behalf of the smaller utilities that are often not under the purview of NASEO. A good chunk of the money that Pat talked about is specifically focused on, if you will, the non-investor-owned utility. And if you compare the geographical size, of 50% of the nation is actually served by non-IOUs, and between 900 co-ops and 2,000 APPA municipal members, you're looking at 2,900 smaller utilities. Many of them are in rural, remote, and pristine areas, right? And they have real energy justice issues. So what can we do for them? Many of them actually probably are still in a level of automation where they're looking at their grids on a cork board with pins, right? Or they may have if they're lucky, they may have an Esri GIS view. These are 5,000 meter, 3,000 meter, etc. What can we do? Because the bias in the industry is, other projects, and I'm not picking on any one, but ADMS projects typically take 5 to 7 years. And the problem with transmission is 8 years to permit and 2 years to build, right? So what do we do quickly from a wildfire and from a grid resilience and safety perspective? So that's where you will find my passion is about. Sometimes, you have to look for the solution that is fast time to value. What can we do quickly for the smaller utilities? Yeah. And so we'll jump to the next page there. And I'm clearly focused on the distribution side of the business, and Karthik will talk on the transmission side. So the United States has roughly 6 million miles of distribution circuits. You can imagine how pervasive that is. Much of which is on private land or the Bureau of Land and land management. So what do we do? You can't be thinking about, taking a planned outage to deploy something. How can we do something quickly where you can install devices like this with a trained line worker who is using a hot stick? He or she can deploy an individual device like this in less than 120 seconds. So there is about 70,000 feeders, as we call them. You can basically install a feeder within an hour. And each of these devices is pretty much got a SIM card in it. It's like a smartphone, right? It's immediately connected, immediately talking to the software in the cloud. And I have just put a number out there. We did our own analysis, and we see that about 88% of the United States electrical utilities are less than 16,000 meters in size. What can we do for them quickly? And our estimate is, even giving for some flex time, we think we can be 100% deployed on the average 16,000 meter utility. If you are 5,000, you're probably fully deployed in 3 business days. What would a solution like this look like? Now, some of them may not have underground. A lot of them will definitely have overhead. And I have shown you an example of one company, happens to be mine, where you're seeing overhead, different kinds of sensors all the way on the mainline feeder, on the laterals as it comes outside a large commercial complex, which may be an airport, a university, a lab, a school, or a railway station, if you will, or a data center for that matter, since we talked about that. And then can you quickly deploy these devices without the need to take an outage? And can you quickly start immediately getting value? That's the opportunity that a company like Sentient offers, which is really a company that offers a suite of analytics that is enabled by cloud-based software. And yes, it does need sensors to provide the data to it. Yep. Next page, please. So let's talk wildfire, right? Yes, there is no silver bullet. Cameras are valuable, drones are valuable, satellites are valuable, manual inspection is valuable. But please train your attention on the timeline on the top of this page. One of the things that we have done as a company is we are now able to detect proactively vegetation touching a power line, ideally before a fire. In this case, we are able to immediately send daily and multiple times email or text updates to those who need to know, saying, these are all your circuits that are okay. We are putting these on the watch list, and these are the ones where we want you to send somebody now. And guess what? The number one problem we face is the team will say, but there is no outage. I will tell you for the record, I also spend time in healthcare. For me, outage is by definition reactive. You want to get ahead of the outage, like it's a heart attack. If it's a heart attack, it's an emergency. You want to avoid that heart attack. You see here, this customer here basically was willing to undergo that change management, deploy a field truck before there was an outage, trimmed that vegetation line, and therefore proactively came back and told us, hey, this could have impacted 48 customers and we saved 21,000 customer minutes, right? That is the beauty of acting ahead of schedule. This is a wildfire safety issue right now, which is a burning platform, no pun intended, for the nation, right? Next page, please. So what's the paradigm shift that I'm alluding to? If you look at the top of the page, you see people are currently operating through a process which is, it's a blue sky day, everything looks absolutely lovely. I have some scheduled inspections I'm going to go do. Otherwise, all things are normal because my SCADA said so. Well, our software is not going to tell you everything is okay. When people get proactive, as they have done with us, and they start dispatching based on even simple traditional sustained outages, there are utilities that have come in and delivered a 20%, 30% improvement in their SAIDI scores, right? The average system outage duration per year, which many of the large investor-owned utilities are measured by. Again, the smaller guys, it's less about reliability, it is about safety. But one example here that we are talking about is, say, Florida Power and Light, which has a minimum of 20% improvement in savings, right? We save them $12 to $13 million a year just on the proactive instead of reactive. Now, the magic of what we are talking about today is the promise of going predictive. There is a webinar with Consumer Energy that anybody wants can Google on YouTube that was done last September. There was a presentation that was made at Distributech with us. And again, we think they are heroes because they went through that paradigm shift and they came back and told us, oh, wow, instead of sending somebody at 2 a.m. in the morning on Wednesday, by sending somebody on Monday morning, we think we are able to potentially save 70% of the operating costs, right? This is based on vegetation contact on power line alerts or potential equipment failure alerts. There is an estimated 25 to 30 million transformers on the distribution grid on these 6 million miles. How many of them are we going to go inspect? How many of them are we going to go replace? This is the fastest time to value at a fraction of the cost of many of the other systems out there. And the beauty is it is using cutting edge AI/ML algorithms based on 200 million plus waveform that we have been working on. And we have over 30 machine learning based classifiers, right? So that is the benefit. The best outage, in our opinion, is one that can be avoided. Can everything be avoided? Sadly, no. But the best outage is something that can be avoided. And we think well over 80 to 90% of these outages can be avoided. There are always the extraneous events that are out of human control. So that's the value of this paradigm shift. And to my colleagues from NASEO, feel free to connect with me on LinkedIn and I'll tell you what the difficulties are with that change management culture, because the mindset of the utilities, oh, this is going to take years. No, it's not. You're talking about business days here before you can bring a level of safety and situational awareness to the national critical infrastructure, which is our grid. Yeah. So next page, what does this value look like, right? So out of the box, you should expect to see the simple things. Like I said, SAIDI bores me. SAIDI is a sustained outage. Why can't we avoid it? If we can, we should. Mayfee, the number of momentaries, if they happen to have reclosers and stuff like that, and if it can safely reclose, it will. And like John talked about, sometimes it is not safe to reclose. So you might buy a really expensive device, and during wildfire conditions, you're going to have to tell it not to reclose. And that's also perfectly okay. But Mayfee reduction is something to be expected. One of the other benefits of a solution like this is extremely high fidelity. We are talking about real time now, meaning 7,000 plus measurements per second, right? That's 15 kilohertz on the overhead side. And by the way, double that, 30 kilohertz on the underground side. We are able to measure current direction reversal, which is very, very important in this day of solar and battery and microgrid and wind and vehicle to grid initiatives. The grid is fundamentally unprepared for bidirectionality. So wouldn't you want to know who is charging where, who is interconnecting where, who's actually selling energy into the grid where, and which feeders, which circuits, which laterals, or which substations are in need of overhaul, rather than saying, I need to overhaul everything. Yes, and we also do load balancing and harmonics detection, because that is fundamentally what happens. You see power quality becoming a more significant issue. I think I talked about the predictive analytics for vegetation and equipment outage. There is also the voltage fluctuation and the reduction solution that can be made available. But we are all on this call working towards a new grid, a bidirectional grid that has got far more renewable energy integrated on that. It is far more resilient because we will have microgrids with batteries out there, and then we can support more advanced applications. And I won't go into the details of any of those right now, but there is a crawl, walk, run here. And my message to the state energy officials is, look, the 3-day, 5-day, 10-day implementation is going to provide immediate situational awareness and immediate improvements in reliability and resiliency, right? So that's the fast time to value. So last page, I believe, if we can toggle to the next one. So what are we doing? I'm so grateful to Kirsten to kind of give us this audience here. We have been in collaboration and talking to various states already. We do understand that, we are a lowly vendor and that is not typically used, but in my personal capacity as a Gridwise Alliance board member, I'm happy to offer unbiased feedback on what kind of technologies will make sense where, and even help with some grant writing capabilities if your organizations need, because Lord knows those smaller utilities, their typical answer to me is, Giri, which one of my 5 projects that I'm working on, which I already don't have people for, do you want me to drop so I can go submit for a grant application to the GDO? That's the sad reality for it. But we also believe that it takes a village. It takes a lot of the national labs coming together. We are proactively already working with great organizations like Oak Ridge and Sandia and LLNL and so on. And we believe this national initiative called the Outage Data Initiative Network, ODIN, is a very, very important one for our national grid resilience, especially in these difficult times. So what we are now working on is to provide pre-failure alerts to the ODIN network. So this is my attempt, as a Gridwise board member, to reach out to you and say, if you need help, do not worry about the fact that there is a company here, but I am offering this to you as somebody who's happy to work shoulder to shoulder with each state, because we want to see all the money that Pat's got for us. We want to make sure it reaches the right levels of different utilities quickly, and we are able to bolster up the grid resilience. So I believe that was my last slide. So I'll turn it back to you, Kelsey.
Thank you, Giri, and I'll turn it over to Kartik to close us out.
Thanks, Kelsey, and good to meet you all. I'm Kartik Rao, VP of Client Success at Line Vision, and excited to talk a little bit about our technology today. So if we could go to the next slide. So I think it was Kirsten that talked a lot about these large grid challenges off the top, so I won't spend too much time on this, but these fundamental unprecedented challenges that utilities are facing is really what why Line Vision was created, particularly that massive backlog of renewable power that's not able to be interconnected into the grid today because of a bottleneck with transmission, and the serving of load growth for the first time in decades. Seeing the demand that utilities need to meet is increasing, and they just simply don't have the capacity to keep up. And all of this is happening at a time when 99.9% of all transmission lines have absolutely no monitoring beyond the substation. So utilities are essentially flying blind, trying to run a system that is fundamentally more bidirectional, more distributed, more dynamic than ever before. And so there's a massive gap in the tools that they have and their ability to deliver on this emerging system. And we have a suite of solutions that we can help to solve those problems. So if we can go to the next slide. So all of that starts with the sensor that we install. We have a sensor that's based on a technology known as LiDAR. So LiDAR essentially shoots out points of light in all directions and times how long it takes to come back. And by doing that, it creates a three-dimensional map of all of their surrounding space. So we can use a LiDAR to look up at all three phases of a transmission line conductor and get really detailed understanding about the position of that conductor in space and time. This allows us to unlock a whole bunch of valuable information about the conductor that can then be used in a bunch of different ways, which I'll get to in a moment. What's really unique to Line Vision about the way we install these sensors is that it goes on the tower and not the conductor itself. And the reason that's important is that for these high voltage transmission lines, we don't require any live line work, which can be extremely dangerous and expensive for utilities. We also don't require any outages, which can obviously be really disruptive and expensive for utilities as well. So we can install these sensors just using simple hand tools in less than an hour. And so we've essentially eliminated the barrier to entry to being able to deploy these really at scale across the footprint of a utility. What's also really interesting about this technology is that while we install this one sensor, we're able to unlock multiple applications, each of which provide different value to the utility. So the first one, and the one that we'll spend the most amount of time talking about today, is our line rate application or dynamic line rating. So that's essentially increasing the capacity of the conductor itself. We also have Line Aware, which is providing operators with situational awareness on their conductors. And we have Line Health, which allows them to protect the asset health of the transmission system itself. Next slide, please. So drilling in a little bit on dynamic line rating. So what are DLR? I'm sure many of you have heard of this technology, but I'll spend a moment just kind of explaining what DLR is all about. So every conductor, every transmission line has what's called a rating, which is the maximum amount of current you can run through that conductor safely before it overheats. And traditionally, the rating has been calculated using what's called a static line rating. So the way we do that is we take assumptions about the worst case scenario. So picture the hottest day of the year when no wind is blowing and that line is already at risk of overheating. What's the maximum amount of current you can push through that line under those conditions before exceeding the maximum operating temperature of that line? And whatever that number is, that becomes the fixed line rating 365 days a year. So of course, it turns out that the vast majority of the time, we're not operating under those worst case scenario conditions. And so we're actually leaving a whole bunch of capacity on the table that's essentially dormant and never used. What dynamic line ratings does is takes real world, real-time conditions on that conductor and uses it to calculate what the actual capacity is on the line at any given time. And it turns out that it's actually the cooling effect of wind that's the single biggest driver of what that capacity is. And so we can use our sensor data, looking at both the vertical and horizontal motion of the conductor, to figure out this hyperlocal wind speed. Coupled with something known as computational fluid dynamics, we can identify what that wind profile is. And coupled with several other inputs, we can figure out what that dynamic line rating is and provide that to the control room so that they know at any given moment in time what's the true capacity that they can push through. And so by doing this, we're able to increase the capacity of the line by typically 40% or more. And what's really exciting about this is that while Gary mentioned when it comes to building a new transmission line, we're often looking at a time frame of about 10 years, because unfortunately there's all kinds of zoning and siting and permitting issues that kind of get in the way. We can deploy this in a matter of weeks at about 5% of the cost of building a new line, and unlock a comparable amount of capacity with just a fraction of the time and cost. And so if we can move to the next slide, please. As you can imagine, because of that compelling value, we're seeing a lot of demand from utilities right now. And so on the screen here is just a sample of some of the utilities that we're working with. Certainly here in the US, we're proud to have partnered with 6 out of the top 10 investor-owned utilities here in the US, but we're also starting to see a lot of demand for this globally. So we're working in the UK, Europe, East Asia, and elsewhere. So if we go to the next slide, we can talk a little bit about some of the specific examples, just to give a bit of a flavor for some of the use cases that we can help with. So just kind of moving around the slide here in clockwise, starting with Avangrid. Avangrid is one of our customers in New York State, and as many of you know, New York has some pretty ambitious goals around the CLCPA for incorporating renewables onto their grid. And like most utilities, Avangrid has a bottleneck problem with their transmission system. And so they're deploying DLR to increase the capacity of their transmission lines to be able to incorporate a lot of that renewable power to help them meet those CLCPA goals. Keeping with New York State, over at New York Transco, this is kind of an interesting use case for us, because this was actually the first customer that decided to install our technology on a brand new line. So having just completed the construction of a new transmission line, they wanted to use DLR to increase the capacity and get the most bang for the buck, so to speak, in terms of their investment. But they also were really focused on the line aware and line health applications, because they wanted to be able to really protect the asset and the investment that they had made in building that transmission line. So when they report out to regulators and other entities, they really want to be able to demonstrate that they're being good stewards of those dollars and really making sure that we're extending the lifeline or the length of life of that transmission line. Next up, we have AES. So they've been a really great partner for us. We're installed both in Indiana and Ohio with them. They're really at the heart of this kind of manufacturing renaissance that we're seeing in this country, particularly with the auto industry, as commercial and industrial customers come knocking on their door saying, we want to build new manufacturing plants in your territory, but we really need to be sure that there's going to be enough capacity for us to run operations smoothly. And so they're relying on LineVision's dynamic line ratings to unlock 50% or more capacity of their existing lines to be able to meet those demands that they're getting from their customers. And then finally, another example is National Grid. This one is actually from overseas. We are working with National Grid here in the US as well, but wanted to highlight the UK example specifically because it relates to offshore wind. So we're seeing a lot of increasing interest in offshore wind here in the US. Over in the UK, they have a lot of offshore wind, but unfortunately their grid is extremely constrained. And that's manifesting as really, really high congestion costs. And unfortunately, that's being borne primarily by the ratepayers, who are really getting hurt with the combination of inflation and increased congestion costs and everything else. So a lot of really acute pain point, and a lot of political pressure around trying to solve this problem. And we're helping them to start addressing that by increasing the capacity of the existing system and reducing those congestion costs overall. Next slide, please. So a little bit about the regulatory momentum around GETS. This was covered a little bit by Pat earlier in the GDO piece of the discussion, and so I won't get into this in too much detail. But suffice to say, the IIJA, the infrastructure law, has been a really great thing. And in particular, the GRIP program has already been a really great benefit both to us and to our customers. We are really excited to have been awarded 2 grants in the previous round. And we're excited to be partnering with a few additional utilities in this next round for GRIP funding. Utilities are really seeing this as a great opportunity to essentially get a 50% off coupon to be able to deploy dynamic line ratings at scale across their most constrained transmission lines. And then over on the regulatory side, some of you may be familiar with FERC Order 881. That was a mandate that's already passed by FERC that's moving utilities in the direction of advanced line ratings. That was for ambient adjusted ratings, which is kind of the middle step between static and dynamic line ratings. But they, as a part of that, they also issued an NOI related to DLR and are currently in the process of investigating a potential mandate for dynamic line ratings. So we're, of course, looking at that very closely. And then in the meantime, there's a couple of other NOPRs related to transmission planning and incentives that are also kind of creating a lot more of the proper sort of alignment of incentives to drive the adoption of DLR. Next slide, please. So finally, how are we engaging with states? We have a fantastic regulatory affairs team led by our VP, Hillary Pearson. And we've been really encouraged to see that legislation is increasingly being picked up at the state level to encourage or incentivize those grid enhancing technologies that dynamic line ratings is a part of. There's currently 9 states that are considering that legislation, and we expect that to grow. And we're always available to help with informing that process in terms of what kinds of technologies are eligible and how to kind of structure the right incentives for that. A couple of specific examples where we've worked with states. One of them is with Massachusetts. We had a seat at the table at the Clean Energy Transmission Working Group, and we were really encouraged to see some really robust engagement on grid enhancing technologies, including dynamic line ratings, and that found its way ultimately into the final report to the legislature back in December. And then finally, with New York State, so that project I mentioned previously with Avangrid, that was a great example of partnering with state governments because NYSERDA actually funded that project, and they ran the Future Grid Challenge program, went through a competitive process. Line Vision was selected, and NYSERDA provided the funding not only to install the sensors across those 2 lines, but also to help fund the process of operationalizing those ratings, meaning integrating the data into the control room so that Avangrid can start using those ratings in day-to-day grid operations. So that was my last slide, and appreciate the time. Happy to answer any questions that might come up.
Thank you, Kartik, and again to all of our speakers. This has been extremely informative, and I think there are already a couple questions coming in the chat, and then those of us on the NASEO side also have a couple. But maybe to kick off the discussion, Giri, I know you dropped your email in the chat, but just for the benefit of everyone on the call, do you mind just giving a 1-minute overview about your partnership with Odin and any other takeaways for the states on the call interested in hearing more about that?
Yeah, no, absolutely. The Oak Ridge National Labs folks in Tennessee are the people who are managing the Outage Data Initiative network infrastructure for the federal government. I think Pat would be aware of that. What we are doing is obviously we are sharing the sustained outage data with them. That's very much the plan. And like I said, sustained outages and momentary outages are not cutting edge, right? So I think the exciting work that we are beginning to do with them is we are jointly submitting for an application that is due for sensor-based analytics by the 4th of this month with a targeted utility. So we have done all the hard work together with the utility and Oak Ridge to make sure we can submit. And that is just the first. So for any state official who wants to rinse and repeat that, because that is indeed my goal, is to make sure we can spread that goodness across the nation. I have put both my phone number and my email for them to reach me. And like I said, my interest is purpose-driven to make sure that we can offer early warnings, particularly to those smaller utilities that often fall by the wayside because they don't have the resources to apply for these applications. So hopefully answered the question, Kelsey.
Yes, thank you. And looks like Sandy Jenkins with DOE's Office of Electricity dropped a link to some more information, but really appreciate you and Kartik both sharing information on how you can support states in accessing different federal funding opportunities or engaging state energy offices in different working groups and report development. But I see another question in the chat, but before I get to that one, just want to remind all the folks on the line to either add your questions to the chat, or since we are in a Zoom meeting, feel free to raise your hand and come off mute, and you can ask either a question or share a perspective from your state on how you are looking at grid sensors. But this question I think I can target to most of the speakers, and it is, how does maximizing line capacity affect asset depreciation? For example, equipment life cycle, faster thermal degradation, shorter maintenance intervals, no effect. And just if you could provide some insights there. Kartik, I see you're unmuted.
Yeah, I'm happy to take that one. It's a great question. So the short answer is that it doesn't have any negative impact at all. And the reason for that is the way lines are thermally limited, there's a maximum operating temperature for which that conductor can safely run. And there's sort of a nonlinear effect that happens once you exceed that MOT. That's really when you start to see degradation. But right up until that point, you're not going to see really any degradation. And in fact, even under the traditional way, a static line rating is operated with the intent that you can run that line up to the maximum operating temperature. The only difference we're doing now, introducing dynamic line ratings, is being able to say that you actually can run more current through that line before you actually hit that maximum operating temperature. So we're providing an increased amount of capacity without additional risk to the line. And what I would add as well is, if anything, because of those additional applications that we unlock around situational awareness and line health, we're actually able to increase the asset life overall, because now we're giving the customer more visibility into things like a risk of potentially encroaching on vegetation, similar to kind of what Gary talked about at the distribution level, as well as other changes to asset health that they might not otherwise have visibility into, that they can take proactive action on. So ultimately, this is both increasing the capacity and extending the life of the asset.
Kartik, does it not bear repeating, right, that with the DLR and the AAR running in the background, you're able to push about 30 to 40% more electrons, right?
Exactly right. Yep, it's a really, really significant increase.
Thank you. And Pat, anything you wanted to add there?
No, I think it was actually covered. It's a great way to provide additional capacity on the line, but look at it dynamically and still yet protect the line from its thermal limits. So great.
Great, thanks. One other question is, most of you, all of you actually talked about how grid sensors can help mitigate risk from wildfires and identify risk areas before the hazard occurs. But there was one question about, when you're engaging co-ops and municipal utilities and encouraging them to deploy these technologies, along with highlighting the benefits, are there any challenges or barriers you've heard from co-ops to actually getting these technologies deployed?
If it's okay with you, Kartik, I'll take that one. And I'll be rather simple and plain spoken about it, right? Kelsey, I mean, most vendors focus on the large investor-owned utilities. You're looking at my commercial team that calls on the 2,900 co-ops and munis. And basically sophisticated solutions like what Kartik is talking about and I'm talking about, you really don't get much traction if you're going through a distributor or a manufacturing rep. No disrespect to some really fine organizations. They are great at selling devices. But when you're talking about AI, ML-based kind of stuff, they don't do. So that's our biggest problem is I don't have the capacity to reach 2,900 utilities, which is why I was so grateful to you and Kirsten that NASEO is helping us reach the states.
Thanks, Gary. Any challenges, Pat, Kartik, or John, you want to flag?
I will just echo that and add to it that the smaller utilities just have capacity challenges with respect to technologies and how advanced their technologies are. The comment was made that some still have the pin charts up, but we know there is investments that's going to be required for the smaller utilities to build capacity and capabilities to really take advantage of sensors, but it's the data infrastructure and the analytics also associated with that. And so that's something that's going to have to be supportive collectively of the smaller utilities so that they don't have to individually each utility learn how to do this. So the information sharing is very valuable. The collaboration and the coordination is extremely valuable.
Pat, that's such a great point that you mentioned, right? So, I call that the instant potato mix recipe, just add water, right? So there was a concept paper we had submitted for the second GRIP that did not get funding, but the whole idea was, what if we could offer our software and analytics across the nation? So all the utilities would have to do would be to buy the sensors, which is the easy part. Unfortunately, that wasn't encouraged. So my plea is to the states is to aggregate as much as they can, because we can't do this one utility at a time, at least at the small guys. Thank you for bringing that up, Pat.
I appreciate that. Anything else the other speakers would like to add before we move on?
I mean, if I could just add, I think, I mean, co-op utilities are generally small utilities, and they are kind of conservative organizations. I think a lot of times when a lot of utilities are interested in, they don't want to be the first one to deploy a certain technology, but they like to be, close behind. So I think that the power of collaboration and sharing lessons learned is very powerful especially for the smaller utilities that might be more likely to do what has always been done before.
Thanks, John. And looks like one additional question actually came in the chat. It was, any best practices on data sharing between different stakeholders, state energy offices, emergency managers, utilities, in terms of privacy and potential implications?
Yeah, I'll take a first shot at that if that's okay. This is really relevant because we were on a call just to finish up our submission for the sensor-based analytics yesterday on this. The response to that falls into two categories: personally identifiable information, PII, which is if we are sending information, if you're not using meter data, you don't run the risk of identifying any personal individual like Kelsey Jones, I'm just taking an example, or the address, etc. Those are PII information. We don't capture any of that as grid companies, right? AMI would be the real risk of that data being exposed. We are not a metering infrastructure play. We are a grid management. But the second one is where we had the most complex conversations, if I may, which is it is a utility's proprietary information on how they have laid out their network topology, and that is the critical infrastructure information. So they are less willing to share that on a public basis in terms of, here is where my transmission lines start and stop, and then here is where my distribution substations are, and I have 10 circuits going out of that in this geography, lat and long. So there is still some conversation going on regarding at what level is it useful for analytics by the national labs. We just had that conversation yesterday, because when I basically suggested the idea of maybe a county level, I got pushback from folks saying that was a little too high for useful, actionable analytics. However, I totally understand this is nationally critical infrastructure, right? Even though the data is fully encrypted, in transit, and at rest, CII needs to be protected. So I don't know. I don't know that there's a clear answer as much as some level of masking, some level of anonymization is required because we don't want our national network in granular detail to fall into the wrong hands. I don't know, Karthik, John, if you want to add.
Not much to add from my end other than security is a really important part of our operationalization process. So when we integrate dynamic line ratings into the control room, as you can imagine, our customers are rightly very concerned about cyber risks and data coming from the outside world into their control room. And so we've really designed from the ground up a security architecture that allows us to really protect their systems and their data in a way that it's really impossible for anyone else with bad intent to get their hands on it. So that's kind of a top of mind aspect to how we engage with all of our utilities.
One thing I would just add is that, you know, it's not necessarily the energy office's traditional role of engaging directly with these smaller utilities. I know, and for Colorado's perspective, I mean, traditionally we've engaged primarily with investor-owned utilities in a regulatory approach. So, you know, I think the first thing that has to be done is just some relationship building with those different organizations. And we had a recent well, working on the microgrid roadmap in our state, we were trying to identify, well, where are the areas that have the highest amount of outages in the state, like how Yuri refers to that as the heart attacks. So, you know, and we were trying to get to a granular level of the feeder level. And so reached out to a bunch of different utilities on an individual basis and sent out a survey and had to like kind of prod people to respond to the survey that because they had the information. I mean, that's not information that's shared on you know, national data sites like the EIA because that's more aggregated to the service territory level. But you know, those grid operators definitely have that information front of mind. That's where they're sending their utility crews to on a regular basis, and they were interested in sharing that with us. But you know, they wanted to ensure that we weren't going to be identifying certain feeders, you know, in a public facing document. So I think just working with them to identify some level of well of just protection of their information is important.
Two quick comments, if I may, John, since you perked up a little bit idea here. I think for the folks from the Grid Deployment Office listening, my suggestion would be at least roll it up to a disadvantaged community level, DAC level, a disadvantaged community block to the extent with the constraints we have. The second thing we talked about was delaying the data feed, so it's not real time. So for the analytics work, I mean, we can send the alerts real time from our platform Ample, but the analytics work, we can delay it by an hour or 4 hours as may be, right? And then the last piece I will mention where I really think NASEO, Catherine and Kirsten, you guys could help us is, it is way safer to actually choose to deploy on an Amazon or Microsoft cloud because of the massive investments they make in cybersecurity than to deploy on-prem. And that is another cultural shift, right? I attended a workshop a year and a half ago where FERC even said transmission class data can be stored in the cloud. FERC has no objection, but I could see some folks frothing in the mouth immediately. So it's a paradigm shift. It's mostly cultural change more than anything else, but cloud actually today offers more high availability and cyber resilience than any on-prem solution.
Well, thank you all so much for that comprehensive response. And I saw, Paul, you put another question in the chat about phaser measurement technologies, and there was some good discussion there in response. So folks, feel free to check that out. But I think in the time remaining, we'd like to just pull up a couple of questions specifically for some of the states and other folks still on the line in the last 10 minutes or so. Just want to give anyone else in the room an opportunity to share how your state is incorporating sensors into short and long-term grid planning, how you're engaging investor and consumer-owned utilities on this topic. Are you running any programs similar to the program John Parks with Colorado shared earlier? What are the strongest use cases for grid sensors in your state? Any challenges? And then what additional questions or technical assistance or resources would be helpful for you? So just want to pause there and see if any of the folks on the line want to unmute and share a brief response to one or multiple of these questions. And it'll be really helpful for NASEO going forward to get more insights from the states as we shape our data working group and other activities in this